At the APL-UW's Center for Industrial and Medical Ultrasound, scientists and engineers explore how to entrap and move kidney stones by deploying non-invasive acoustic waves, much like the concept of the tractor beam as seen on Star Trek.
Tractor beam is kind of this colloquial term. Doesn't sound very scientific, sounds like science fiction. But these acoustic waves can be focused, so they can be focused beyond the stone, next to the stone. And those waves create pressure. And so that you can build basically a cage of pressure around the stone.
I'll talk about the use of focus ultrasound.
Working in collaboration with APL-UW, Oleg Sapochnikov of Moscow State University's physics faculty goes on to explain.
When the stone or other object is in this region, then it is trapped. And so if you now shift the transducer, then the stone will follow the transducer movement.
You can kind of electronically steer that stone.
The idea of moving and steering kidney stones attracted graduate student Mohammed Ghanem.
I took Mike's acoustics class and I approached him about any exciting new research, and then he introduced me the work that was being done with developing a transducer that's a tractor beam, able to move objects in 2D and even 3-dimensional.
For the APL-UW research team, the key to acoustically steering stones with compact, user-friendly hardware is centered on an experimental transducer.
I worked on a system when I was an undergraduate that flew on the space shuttle to levitate drops.
The shuttle has cleared the tower.
These forces have been known, but usually you need transducers from all sides holding it there.
It's a focused transducer.
We're doing this all with one transducer.
He said in the email, he sent me like, we have a 256 element array transducer, and I was like, I haven't seen it when I came here, so I wasn't sure what he was talking about.
Mohammed soon found out.
The whole purpose of the transducer is we can apply phase delay along the surface of transducer, and we can basically change the shape of our acoustic force from, so when there's no phase delay, just strong force and it's a beam. We can push things. But by changing the topology of the phase delay on the surface, we can make a donut shape where it can become wider and wider. So we can actually capture or trap objects that are larger than the wavelengths.
We're further developing our technology to grab the stone and be able to drag it along the ureter. These obstructions are really the emergency condition that drive people into the emergency room on weekends, at nights, early in the morning. When those stones get stuck, there's a backflow of urine in your kidney that expands the kidney, and that is what causes the pain that people experience with kidney stones.
Grabbing a stuck stone with a tractor beam transducer could unstick it.
Slip it down maybe into the bladder or pull it back up into the kidney and relieve that obstruction.
We can use it to collect debris from kidney stone. After a stone breaking process, there's usually debris left around. So what we can do, we can trap all the debris and we can steer them outside the kidney.
We're working on two fronts there. A very complicated system in the lab to make exactly the beams we want and advance the most complicated, best working ones. But we're also getting straight to the clinic and trying this with the existing system we've built that can push, break, image stones.
And next, grab and move kidney stones with a tractor beam. Science fiction transformed to therapeutic reality.
Science at work for you. This is APL, the Applied Physics Laboratory at the University of Washington in Seattle.